Hi students, so today we will see in thermodynamics. Next topic is entropy, availability and irreversibility. So this is most important topic in thermodynamics. So we will see one by one. So first we will see about what is entropy. So entropy, I think we studied in our schooling +1 +2 also little bit about what is entropy. So entropy is nothing but it is a measure of unavailable energy in a particular system. So what is the unavailable energy? So what is available energy and what is unavailable energy? By saying the name itself we can identify the meaning for unavailable energy, but technically what it is giving meaning, what is the meaning for unavailable energy and how that is related to entropy. Why I am saying entropy is the measure of unavailable energy. Okay, so what is that means? If you take an example as an engine, okay, so you are giving some heat supply as an input. Okay, so what it will do? So some amount of work only it will be converted into useful work. So the how much amount of work which is done by the engine is by using the available energy, and some amount of work is not done. Okay, so that is not done because of some amount of heat is rejected from the system to the surrounding or to somewhere. So what I am trying to mean about entropy, how much amount of energy or heat energy that you are giving to the system, okay, that is not completely converted into work. Some amount of energy only is consumed to do some useful amount of work. Definitely, as per second law of thermodynamics, some amount of energy will be rejected, will be removed from the system. So how much amount of energy is unavailable? Okay, so because of that some amount of work is not done. So the measure of that much amount of unavailable energy is entropy. Okay, so now you read the definition. It is a function of a quantity of heat that shows the possibility of conversion of heat into work. What is the possibility? What is a certain percentage amount of heat that is converted into useful amount of work? How much amount of heat is converted into useful work? That is available. How much amount of work is not converted into useful work? That is unavailable energy. So higher the entropy, lesser the availability of work. So that's what I given in bars. Maximum entropy equal to minimum available of conversion of heat into work. Minimum available of conversion of heat into work means that is unavailable energy. So the maximum entropy will be indicating the amount of unavailable energy. If the unavailable energy is high, then the entropy will be high. Okay, it is indicating the unavailable energy in any particular system is entropy. Okay. Next. So here there are three cases. These three cases are most important in entropy point of view. Case 1. So entropy you can denote by the formula cyclic integral of dq by t, or you can say ds equal to dq by t. So this case is different, that we will see in the upcoming classes. What is ds is, why ds is equal to dq by t, and what is dq by t mean? The temperature changes with respect to change of heat, with respect to change of heat transfer. If you supply heat or if you extract the heat from the system, based on supply or extraction of heat, the temperature of the system will change. So the ratio of dq by t is the entropy change. Okay, so that some amount of heat is getting transferred, due to that the temperature of the system is changing. If the temperature is not changing, then the amount of heat is not particularly transferred to the particular area. So that unavailable energy. So that is indicating the entropy. ds is equal to dq by t is the entropy formula. Okay, so now I am considering three cases. In case 1, what I am doing, suppose I am considering this is one system. In this system I am supplying a heat which is dq. Okay, suppose if I supply a heat q, so what will happen? The heat will transfer, it is entering here and it will leave here. This you take as a q1 and this is q2. Okay, what is happening? Suppose if it is steady state, then q will be remains constant, it will not vary. So the transfer of heat is dq. Okay, that is dq. Due to this, how much amount of temperature is varying? okay, that is dq by t. If I supply the heat, okay, to the system, okay, then the dq by t ratio will be positive. If I supply the heat, what will happen? The temperature of the another system, means this is the system, to this system I am giving heat, okay, and otherwise from here to here the heat is coming, okay, heat is transferring from here to here, it is giving the heat to the system. Then what will happen? This body temperature will increase. So if you supply any heat to another system, that another system will get heat, so that the temperature will increase. So the supply of heat to any system will be in positive. So ds you can write, instead of ds, it is a change in entropy, which is S2 minus S1 will be positive when heat is added to the system. When you add the heat to the system, then the entropy will be positive, so that S2 is always greater than 1 when you add the heat to the system, right? Next, when you remove the heat from the system, what will happen? Then the dq by t ratio will be negative, so that S2 minus S1 will be negative, then S1 will be greater than S2. That is case 2. In case 3, that is adiabatic process, there is no heat transfer. If there is no heat transfer, then this term will be equal to 0. When dq is equal to 0, S2 minus S1 equal to 0, then S2 is equal to S1. Okay. So in your syllabus, power plant engineering subject also given. I think you might study the power plant engineering course, where you have studied the Rankine cycle, that is a steam power cycle. In steam power cycle, there are 4 important components like boiler, steam turbine, condenser and pump, where it is assumed that in pump and steam turbine, the process is isentropic expansion process. In isentropic expansion process which is happening in turbine, why it is assumed as isentropic expansion process means, where they are considering there is no heat transfer in the system, means we are not giving heat to the system and there is no heat removing from the system. We are not adding any heat to the system and there is no heat rejection from the system. That is adiabatic process. Okay. So in adiabatic process, heat transfer will be equal to 0. When there is no heat transfer, there is no change in the entropy. When there is no heat transfer, when Q equal to 0, then entropy will be equal always, so that S1 equal to S2. So these 3 cases you please do remember. Okay. Next, same case, I am taking a reservoir. If you see our previous session where we have discussed about the concept of heat engine, heat pump and refrigerator, where we have seen about the heat source and heat sink. Okay. So the source and sink both are thermal reservoirs only. Okay. Suppose source is the supplier of heat. Okay. Even though if it supply enormous amount of heat, its temperature will never change. It will be at fixed level only. So that is a thermal reservoir. But in source, what is happening? Source is supplying the heat. Okay. So source is supplying the heat. When it is supplying the heat means what? That will be negative, as we have already discussed. When you remove the heat from the system, then the entropy change will be negative. So that ds is equal to minus dq by t. So for source, that's a thermal reservoir which is supplying the heat to any system, means it is rejecting heat. Okay. So the heat is removing from the system. Then the ds will be minus dq by tt, dq by t. Then S2 minus S1 will be negative, then S2 less than S1. Okay. Here sink means what? It will receive the heat. Okay. Even though it is a thermal reservoir, sink also thermal reservoir only, even though if it is receiving more amount of heat, its temperature will never change, it will be at constant level only. But as per our entropy concept, in 3 cases we have seen, when any system receiving heat, then the entropy change will be positive, right? So here ds is equal to dq by t, this term is positive, so S2 minus S1 is equal to positive, S2 will be greater than S1. Okay, this also you do remember for entropy. Next, availability is the next topic. Availability, it can be further classified into available energy and unavailable energy. Okay, so what is available energy and unavailable energy, we will see one by one. First we will see about available energy. Okay, so this is the heat engine. What I am doing, this is the heat engine. I am giving some, like you take our engine, okay, our petrol engine, our bike engine. I am supplying heat to the engine. Why I am supplying heat to the engine? Because when I supply some amount of heat to the engine, the combustion process will initiate. That is pure mechanical engineering topic I am talking about. Inside an engine there is a combustion process. Due to that the power stroke is happening. So during power stroke the vehicle is moving. Okay, so the input is heat. When I supply some amount of heat, some amount of mechanical work can be done. Okay, that is the concept of heat engine. So I am supplying heat from the source to the engine. So by supplying this heat, I can able to produce some amount of useful work. But as per Kelvin's Planck second law of thermodynamics, that laws and all I have taken already one video. If you want to know about first law, second law, zeroth law of thermodynamics, see my previous session. Okay, so W is amount of useful work converted from the amount of heat supplied, and as we have already discussed, no engine will give us 100% efficiency. Always there will be some amount of heat rejection, right? So from here to here the amount of heat is rejected Q2 and useful work is done as W, right? So efficiency means output by input. What is the output? W. And what is the input? I am supplying Q1. Okay, this I can this is one big derivation. After that small derivation. After that I got this, I have derived already in the previous session. If you want to see, you please refer that video. So that the efficiency is this W by Q1 equal to 1 minus TL by TH also I can write. Now I want to know how much amount of work is done. That is the available energy, right? So W is equal to, I can say, multiplication of this Q in into this 1 minus TL by TH. So the available energy means what? I have sent some amount of heat energy. How much amount of energy is converted into work, into useful work? So the amount of energy converted into useful work is called available energy, right? Now next, unavailable energy. Unavailable energy means what? So as we have discussed, we are supplying you consider this is an engine cylinder. I am supplying a heat so that the piston will move, so that will give the motion to the vehicle, so that some amount of distance that I can travel, because that distance how much I am traveling is the amount of useful work is done by the system, right? By giving some amount of heat supply, the vehicle is moving from one place to another place. Suppose if I fill 1 liter petrol, how much distance that I can go? Okay, so I cannot travel more than 50-60 kilometers in 1 liter petrol. Okay, so that amount of heat is supplied is, you just consider as how much amount of fuel that you are filling inside your petrol tank. By using that much amount of fuel, how much amount of filling the fuel is input, that is heat energy I am supplying, and distance traveling is output, that is amount of useful work, that how much distance I traveled is amount of useful work, that is unavailable energy. What is unavailable energy? Suppose I want to go to 5 kilometers, but I can travel only up to 1 kilometer, because this much amount of energy only I have given as input. With this I can do only this much. Then why I am not able to travel further? Because some amount of energy is rejected from the system. Okay, so some amount of energy is rejected. That energy which is not available inside the system is called unavailable energy. The energy which is not available inside the system, the energy which is rejected from the system is called unavailable energy. Hope you clearly understand about what is available energy and what is unavailable energy, right? Now I also will explain you the unavailable energy with the help of the TS diagram. So this upper side, there are two rectangular boxes I have plotted here. This is the temperature and the entropy relation, where suppose you take, this is the highest temperature of the system and this is the lowest temperature of the system. Okay, what is happening in petrol engine? There will be some concept that we will see in the upcoming classes about what is Otto cycle, DC cycle, where I will discuss in deep about this. Now you just see, always already I have mentioned in the previous session. Okay, so here this much amount of work is done by the system. This is the amount of available work is done by the system. Okay, so this much only it can do, but some amount of, what I said, some amount of unavailable energy will also be there, means the amount of heat is rejected from the system is unavailable energy. So this particular violet box I have marked is the amount of unavailable energy. Okay, so how to find out the unavailable energy? The formula for the unavailable energy, you have to consider only this particular section. Okay, this particular section is in rectangular shape. By seeing this, we can define the formula for unavailable energy. So what is unavailable energy? So this is a rectangular box. What is the area for the rectangular? Length into breadth. Okay, so what is the length? It is S2 minus S1 or ds. What is the width? Which is TL. This temperature is TL. So the unavailable energy formula is TL or T naught, the initial temperature, okay, or Ti, anything you can take, or lowest temperature, initial temperature, okay, you can fix. Somebody they will say T naught, somebody they will say Ti, and I am noting this as a TL. Okay, TL into ds. ds means change in entropy. So the unavailable energy formula is TL into S2 minus S1. This is the formula, you please remember. Okay. Next, irreversibility. It is also an important thing, just you do remember. Okay, and one more thing I forgot to mention here, the amount of heat I supplied into any system will be the part of available energy and unavailable energy. Do you agree that? What I have already mentioned you, I am supplying some amount of heat. Why I am supplying? Why I am giving this input to get? I am expecting that all amount of input that I am giving I will take as a output, but in reality that is not possible. Okay, so that how much amount of heat that I given to the system will be in the form of available energy and also unavailable energy. So the amount of heat added to the system will be the summation of available energy and unavailable energy. Okay. Next, now you come to the irreversibility. Suppose you take, this is the total energy of the system. This is the total energy of the system. Okay. Suppose if, what is the total energy means? This is Q1. Total energy means Q1. Okay. So that is the total energy of the system. Then in Q1, what is the two things? One is available energy, another one is unavailable energy. These are the two things in the heat supplied. How much amount of heat that I supplied? One is available, another one is unavailable energy. Now, what is our topic, which is irreversibility? So, what is irreversibility? Irreversibility in the sense, what is that? Some amount of irreversibility is the difference between maximum amount of work done to the actual amount of work done by the system. So, what is the actual amount of work done and what is the maximum amount of work done by the system? There will be already some amount of unavailable energy is there. Okay. Due to that, some amount of work is not completely converted into useful work. Then, what is the meaning for irreversibility? Irreversibility is the difference between, reversible work or idealized work and actual work. The maximum amount of difference between maximum amount of work to the actual amount of work is called irreversibility. So what is meant by maximum work done and what is meant by actual work done by the system? Maximum work done by the system is always ideal case. Okay, no system will do maximum amount of work. There will be some amount of losses, like heat losses will be there. Okay, that losses are called irreversibility. Due to that, the system will not give 100% output. Okay, so that losses we have to take into account. Okay, so you can say some friction losses will be there, some amount of heat will be rejected through the silencer of the engine. Okay, if you take a boiler, some amount of heat will be sending out through the exhaust gases. The exhaust gases will come to chimney, then through chimney the exhaust gases will leave. Then in the exhaust gases also some amount of heat will be present. Okay, and in boiler water is there, water also will carry some amount of heat. So these are the some factors or parameters which are also taking the heat from the system. Okay, so that all factors are coming into account, which is not allowing or not letting the system to give 100% efficiency. So that is actual work. In reality that will be there. Okay, so you cannot run the boiler without sending any water inside. So boiler, main aim of the boiler is to produce the steam. Okay, how it will produce the steam without availability of water, and is that possible to, will you operate the boiler by not sending out the exhaust gases? You have and must, you should and must send out the exhaust gases from the boiler. You should not, you cannot keep the exhaust gases or flue gases inside the boiler. There will be some amount of heat which will go away along with the exhaust gases. Okay, so that are all the parameters or the reasons for the system which is not giving you the 100% efficiency. So the difference between actual case and also the maximum work done between the system is called irreversibility. So irreversibility is the difference between idealized work and actual work. Okay, and this is the common formula, I is equal to T naught into ds. This formula you do remember. Okay, so there is one derivation which is not available in your syllabus. The reversibility formula only you do remember. I can take the derivation, but that is not important. Okay, so the formula for irreversibility is T naught into ds universe. Universe means what? System plus surrounding. Okay, so ds universe is equal to ds system plus ds surrounding, and this is the general formula for irreversibility. Okay, so I is equal to T naught, like you can say TL also, T naught or TL, both are same. Okay, which is equal to T naught or TL into TS into universe. This is the formula for irreversibility. So that today we have seen what is entropy, what is availability, and what is irreversibility. Okay, thank you. In the next class we will see the upcoming topics. Okay, thank you.